those of you who don't know, if you know you're going to be absent, like all of us on a college visit, you didn't want to miss class, we can record class for you. I have to just use my own voice. That picks up volume almost perfectly from an entire room. So it will record what Paige is writing, what anyone says in class. So if you know, particularly seniors, if you know you have a college visit planned, let us know. We can record it for you. Then we'll send you the recording. Okay? And then Paige, as the note taker, I'm just going to print out the notes she takes and she'll have them on paper. All right? Okay. Let's continue. So we know from last night's homework, the indefinite integral is asking for you to take an action. The verb is to integrate or anti-differentiate. And the solution to an indefinite integral is an infinite number of functions, hence the plus c, because we don't know what the plus c is. So up until now, we know something like this. So if we have something like this, I'm going to start easy, just because I want to make the point that has something to do with this right now. If I were to differentiate this, or take the indefinite integral of this integrand, I will get x cubed over 3 plus x squared over 2 plus 3x plus c. Okay? Generally speaking, when we talk about this because of the plus c, this describes an infinite number of antiderivative functions. It's a mouthful. A number of different antiderivative functions. To be really, really clear for a second, if I were to use my function notation, when we are taking the indefinite integral of something, this integrand is the derivative. Okay? That's the derivative. And what we are finding is f of x, right? We're finding the family of functions f of x. So this is nothing new here. What's really, really fantastic, and the most important day of our lives is in exactly 7 days. It's the most important day of our lives. It is, please do not ruin the surprise. Really, your look at me is a combination of confused and weird. Like, you think that I'm either confused or weird or both. I embrace all sides.
But what's happening in 7 days?
It's a party.
For what?
It's the FTOC. It's the most important day of your life. Okay. Wait. Okay. That reaction tells me.
Let me Google it.
That reaction tells me.
You know what it is? Tell me what it is.
That reaction tells me you did not fully embrace the magnitude of the FTOC. Okay. It's the most important day of your lives. The countdown has begun. 7 class days. Okay.
You
will not Google FTOC. This is the reaction that you will have in the future after this party. So note Kate's reaction. When I said FTOC, she said, after the most important day of your lives, when you go forward and someone says the FTOC is coming, you will react like, oh, like it's a big step back reaction. Okay, that's the most important day of your life. 7 days. Yes, it is huge. Oliver, 7 days. The countdown has begun. 7 class days. It is the most important day.
You want me to Google it? FTOC?
Speaking to Oliver beyond the grave or whatever. Why would the C be in the middle?
Hey, Oliver.
Okay. Okay, let's bring it back. So that's the countdown. As we get up to that day, I'll be sending around with a Google Doc for us to bring in various things to eat and drink. It is a party.
Oh, it's an actual
It's
party.
not like a.
Oh, I thought it was like a party that's got like a quiz that's disguised as a
No.
party that
No, it's not a Halloween costume.
It's the kind of party that people come up to you and ask questions about math.
Wait, so this is like a local party. Like, we're gonna have food and drinks. Oh, in one day?
Somebody else.
Okay, I'm going to digress. Ready? Now, so let's bring it back. But the point is, I would look at your calendar and just make note that in 7 days, your life is going to change. All right? When you're taking the indefinite integral, you're taking the indefinite integral of f prime. What you are finding is a family of antiderivative functions f of x. The only way you can narrow down from a family of antiderivative functions is if you are given a situation like this. So note my red marker. Let's say, I'm going to rewrite this problem. Let's say that the antiderivative of x squared plus x plus 3 equals dx, okay? This is, again, f prime of x. And we are told that f of 0 equals 1, okay? This is the added detail. So look at the presentation now. Now you are given an indefinite integral to evaluate, but the addition here is you are also given a point, a single point on the antiderivative function. This is what is new. The given information has increased a bit, and that bit is a point on the antiderivative function. Well, let's proceed. So you know from last night, if this is your indefinite integral, you know that your family of antiderivative functions is going to be x cubed over 3 plus x squared over 2 plus 3x plus c. And what you have found here is your family of functions f of x. But if you know that if f of 0 equals 1, you can solve for c, because this is saying when x equals 0, f of x equals 1. So you know, plugging in 0 for x, we get 0 plus 0 plus 0 plus c equals 1. Okay? If c equals 1, then you have, okay, boys, I need you to stay like right here. Please don't be distracted. Then you have your specific solution. F of x equals x cubed over 3 plus x squared over 2 plus 3x plus 1. This is no longer a family of antiderivative functions. This is now a single solution, a single antiderivative function. Or it's called a particular antiderivative function. Okay? So very, very important. Depending on the task at hand, depending on the given information, your solution will either be an infinite set of functions or a single set of functions. Okay? Now, the natural question is, okay, let's go and revisit rectilinear motion. Okay? Let's go back and let's present ourselves with a situation. A particle moves rectilinearly. So, or I can say on an axis. Okay? And you know the velocity function is, okay, let's see, I'm going to do 3 cos t, okay, minus root t. You know that. And you know S of 4 equals -2. All right, so let's back up. A particle moves rectilinearly such that the velocity function is given, and a position at a point in time is also given. I'm also going to add this added detail. Let's say, because we're talking about rectilinear motion, t is generally time. I'm going to specify that t is bigger than or equal to 0. Okay? S of 4 equals -2. Okay, so looking at this, part A. Let's do part A together, and let's talk about how we set up, because the work we write, and I said this last year too, those of you remember, I'm very particular about the fluid and the clarity and the readability of your work, okay, the cleanliness of your work. If we're finding position from velocity, you want to take what action on the velocity function? You want to integrate it. Now, we are going to integrate. We're going to take the indefinite integral of the velocity function 3 cos t minus root t. I have said nothing about the dummy variable up until now. That's on purpose. I will in a bit. Right now, all you need to know is that the dummy is always there, and the dummy's variable must match the independent variable of your integrand. So it makes sense, it's been dx up until now. What should the dummy be here? dt, okay? I will meet you on the far end of this after you integrate. Go ahead, touch base with someone next to you. It should be not too painful.
Sorry. Sorry.
So, cosine, so
Sine is the inverse, so 3 sine t.
minus, and then square
Then
root t is
square root is
just t to
same
the
as
1
t to the
half.
1/2, yeah.
So you
it's-
add 1, which would be what? 3 halves.
Yeah.
So then you do
Then you
1 divided
divide by
So 2/3 t to the 3 halves. Yeah, 2/3 t to the 3 halves plus c.
It's 3.
That's a good idea.
This thing's really hard to write on. My notes have never been this messy.
Mateo Jabril, can I have the antiderivative, please? Before you find the particulars, right? The family of derivatives first. You're still doing it, okay? Fair enough.
I feel like I got it wrong.
It's okay. Be loud, proud, right? We are with you and behind you all the way, Jabril. Come high or low.
Okay. 3 sine t minus t to the 1.5 power 1.5. Sorry.
Yeah. Minus t to the 1.5 over 1.5. You're gonna want to, just because it's gonna be
Yeah,
easier.
sorry about that.
Okay. Plus c. You're also gonna want to clean this up.
Let's see.
Did you say plus c, Jabril?
Yes, yes.
Okay. Plus
100%.
c. Plus c.
Yeah.
Now, since we know s of 4 equals -2, let's see, this is where you can use a calculator. There's going to be a calculator involved here. Okay. That means this here is the family of position functions. I need a specific position function that obeys the fact that at time t equals 4, s should equal -2. -2 equals 3 sine of 4 minus 2/3 4 to the 3 halves plus c. This would be calc active because of this 3 sine 4. I'd like to can I have the approximate? If you have the approximate, I'd love to have it to 3 decimal places would be great. What does your c value equal? Okay. C, are you in radians, Cameron?
Yes.
-7 point, one more time, -7 point. Great, -7.603. I am out of room vertically, but just make sure your work is clean. Therefore, the particular position function is 3 sine t minus 2/3 t to the 3 halves. My constant is minus 7.603.
So if that's defined as a t, that like by default that's not function, that's a function.
Well, I know it has to be because if I'm given the velocity function, I'm given 1 point. I guess you need to find the particular position function. Okay? Tell me why you would need to have a position function. Oh, yes, fair enough. What kind of question can I now ask? I can say, what is the particle's position at 7 seconds? Okay? In fact, if I cut out part A and I gave you the same givens, and I said, find the particle's position at t equals 12 seconds, you would have to first find the particular position function. Everyone okay? All right? Cameron, yes.
I was wrong because I forgot that there's a negative on the other side. It's +5.
Okay.
Point.
All right, change your constant. Cameron found a mistake. Positive 5.603. Positive 5.603. Thank you. Okay. Everyone, okay. Fantastic. Okay, let's do this. You are going to see this phrase in your textbook. Questions like this, where you are given a derivative function, whether it's in this context or presented like this. Questions where you are asked to anti-differentiate and then find a particular antiderivative from the set of infinite. They're often referred to as initial value problems, okay? Let me tell you why they are called that and why I don't like for us to fixate on that name. Initial value problems is often the point of reference because the point given generally, more than 50% of the time, the point given is generally at t or x equals 0. But as you can see, it doesn't have to always be. You can have a data point when x equals or t equals not 0. But initial value problems, okay, that's what these kinds of problems fall under the heading of. All right, we're about to merge two ideas beautifully now. Merge two ideas. Do you remember our good friends that we touched, saw, and then left fairly quickly? No. I'm hearing no.
Vectors that were not on the
Slope fields. What's recall?
Sketchy, I feel like.
Slow fields.
Okay.
Let's recall.
Oh yeah. Touch saw.
Let's recall slope fields. Okay. Come on back. Let's recall slope fields. I'm going to give you one that we can craft fairly swiftly. When you write this differential equation down, let's go ahead and just put in the slope field, and I think we can just put in 0, 0, 1, 0, 2, 0, 0, 1, 1, 1, 2, 1. Okay, remember these? Okay. Let's just say do that. Complete the slope field. That's part one. Okay. You're smiling in a way that makes me suspicious.
I like math, what can I say?
Yeah.
You have your expression is one of a cat that just ate a mouse, which means happy. I'm wondering what you did though.
Nothing, I just asked like,
Detected us from.
Nothing.
scary vermin.
Okay.
Are
Let's see.
you
Let's see.
implying that I'm like a quadruped, four-legged creature?
Wait. Did you say quadruped?
Four-legged, I realize that. But
Yeah, that's redundant.
Hey, gentlemen,
You're just a
gentlemen,
quadruped.
I do need you like party of boys over here. Bring it in. Let's bring it in. Shreya, yes.
Are we doing the slope field of DYDX?
Yes.
Oh.
Slope field of this. Okay? That's part A. Okay. Let's see. Here's part B. And we're going to pull this together. Like I said, we've got a pretty meaty agenda today. We're just about at a point where I can then kind of up the ante a little bit. There's that. Now, look at this notation. Okay. Then here's part C. Okay. Slightly different notation. I mean, there's nothing wrong with that. Complete the slope field means you're going to craft the slope field. Part B is saying if y of 0 equals -1, you're asked to find y of x. Okay, so this is what we just did, part A and B. But then part C is asking you to actually superimpose and sketch y of x on this slope field to make sure we pull all those kind of stray ideas together. Okay.
Why does it just seem that?
That's right. Y of x, just say the y is a function of x. Y of x is just a function of x. Yep. All right, then let's swing this coordinates. Yep. Nice. Nice. Now I'm going to just kind of mosey around here because we all seem to have the same slope field, and that doesn't require conversation. Then I'm just going to go put the slope field up. If it does require conversation, we'll talk about it. There we go. There we go. There we go. Yes. All right. So I'm just going to bless you and bless you.
Like it would just be a flat.
Slope field, that's would be great?
Yeah.
Okay.
Yeah.
Now that should make sense because when I see dy dx, I can even think to myself, well, the antiderivative family of functions is, what is it? 1/2 x squared plus c, okay? And I can see that I could add more points, but I can see I have 1/2 x squared plus c, vertical translation. When you go and find the particular function y of x, make sure we're all on the same page. Do we all have the same particular function y of x? Did you get to y of x equals 1/2 x squared minus 1? Okay? Then if you go back to your slope field and you superimpose this on the slope field, you should have a curve that pretty much obeys, correct, the kind of direction of your slope field, okay? Now, here is the thing. In this context, you're going to hear all these phrases, and I tell you all of them because that way you'll know textbooks differ. Questions may differ. You may see phrases like this, integral curve. You may see the phrase solution curve. You may see the phrase family of integral curves. I don't know, I know next year's text for multivariable, it goes between the first two. Your text here, I think, sticks with the first one. That's really talking about solution curve. But this purple, or my purple, this parabola that I sketched is a particular integral curve. It's a particular solution curve. It's referring to the solution of this differential equation,
If this is 0
the specific antiderivative function sketched on the slope field.
That's where I messed up.
Okay, so all those phrases are fair game. I mean, this is often referred to also as a solution curve. The family of integral curves is what the whole slope field as an entirety suggests. Okay? Take a nice pause there to make sure we've got kind of these few ideas. Jason, yes?
So is the family of integral curve like a lot of functions? Yeah.
Yes. That would be, it would be a question like this. Sketch the slope field, and then sketch a few members of the family of solutions, right? And you'd sketch several parabolas, right? The question could say, given this, sketch the particular integral solution or integral curve on the slope field. So those are all different ways of phrasing that. Let me pause here before I move forward. All right. Okay. All right. Let's see. Okay. Now we're here. So we're taking a significant jump right now. The task of anti-differentiating. If you think about all of the derivative rules we learned last year, level 1 is just the straight up derivative rules in reverse, like the product rule. the power rule, the derivative of ln x, the derivative of sine x is cos x. But then you had things like the quotient rule, the chain rule, implicit differentiation, the product rule. There has to be integral rules that pair with each of these. So when we have something like this, so I'm shifting gears now, okay? When you are asked to integrate, we have to kind of follow a triage. The first thing you look for is, can I recognize a derivative rule in reverse, either immediately or with some algebraic manipulation like last night's homework? That's the first thing you check, okay? Then you have something like this. I hope it is clear to you all, it's obvious to you all, that this is not the result of any of the derivative rules of the basic derivative rules you've seen, correct? Okay. Here's what we're gonna do. This is one place where I'm going to show you the method. It is very step by step. I'm gonna step back and say why this method works. I'll give you the name of it, and we'll do several examples. I will say this. Initially, I'm going to ask you to show all the steps of the work and all the adjustments you make, and you may not believe me, but in very short time, you'll be able to integrate this in one step, okay? Here's what we're going to do. Cameron. Oh, is there any question? No? Okay. First observation. Do you observe here that in the integrand, within the integrand, listen to the words I'm saying, within the integrand, you hopefully notice that there is a composition of functions, namely here, cosine of 5x squared. In other words, the 5x squared is inside cos x. Do you understand? Okay? When you have that, this is a good thing to try. Unfortunately, in calculus, there are no rules that work all the time. But when you notice a composition, it's worth trying this. Ready? We're going to substitute. Okay, we're going to substitute. U, I'm choosing U, substituting U equal to that inner function. U equals 5x squared. Okay, yep, right? Okay, yes, that's right. Okay. When I have u equals 5x squared, if I were to take the derivative of this equation, and I wanted to use the d something, like the dy dx notation, this would be d blank by d blank equals 10x. What are the blanks? D. Do you understand? Yes, right? du by dx equals 5x squared. Everyone understand? Oh my gosh, thank you. 10x, yep. Everyone okay?
Oh, yeah.
Ooh, we back up.
Right here? Yeah, if you're wondering how I chose that, you don't know quite yet. I gave you a hint, which was, notice that there's a composition of functions right here. I'm letting u be the inside function. Okay, I'll talk about that a whole lot more. Okay? Once we have u equals 5x squared, this is a correct statement. Everyone okay?
Wait.
I'm going to take this equation, listen please, I'm going to solve it for the dx, which means, come over here, multiply both sides by dx. The first time you're seeing us separate out the two differentials. I'm going to multiply dx by both sides. du equals 10x times dx. This is the first time. This is significant. This is the first time we are treating dy dx almost as like a fraction. Solve du divided by 10x equals dx. Okay. What have I done so far? Oh my gosh, I think I'm having mouth to hand agreement issues. Sorry. Okay. Oh, never mind. What was that, Jabril?
I'm just expressing that.
What, from what part?
I mean, I understand that, but I'm just saying how it fits into like the figure.
Of course. I think that's a natural, I expect it to be right there. Okay, now are you ready? Here's what we're going to do. With this choice, I'm going to rewrite this indefinite integral in terms of x, integrands in terms of x, Dummy has to be in terms of x. I'm going to rewrite this integral from an integral in terms of x to an integral in terms of u. And let's see what happens. Ready? This should equal, okay, the indefinite integral, well, let's see. Argent, this is still 3x, okay? 3x cosine of u, right? Dx is now du over 10x. Watch me, please. Du over 10x. I'm going to now step back. This should bother you. The dummy is u. That means the variable in the integrand should be only, but you see the x's. But the x's do what? They cancel, okay? So then we get here equals the indefinite integral of 3/10 cosine of u du. I'm going to pause for a second, and I'm going to ask that, those of you who saw this before, appreciate how this was very awkward at first. Your natural question was likely all of yours, which is, how on earth did I know to pick u? What if I picked the wrong u? How do I know to pick the right u? Okay, we'll answer all of those, but let's just stay with me here for a second. Now back up. Do you see this indefinite integral? The indefinite integral of 3/10 cos u du. Do you all see this?
Yeah.
Okay. Do you see that this is now a simpler integral that I can now anti-differentiate? This is 3/10 sine of u plus c. Okay? However, there's a big however. We have to obey kind of the question as it was initially presented to us. The question was initially a task that you were asked to do in terms of x. We have to express our answer in terms of x. 3/10 sine of u plus c. Is there a way that I could rewrite this in terms of x? What do you think I could do?
Like that.
We said u was 5x squared. So this then becomes 3/10 the sine of, not u, the sine of 5x squared plus c. And that is my family of antiderivative functions. Okay, yes. Yes, all of yes, of course. Okay? We know. So what I'm saying to all of you is, believe it or not, all of you will very quickly be able to do this from here, skipping all of this, going right to here. It will take a few days. For tonight, I want you to write all of this down. I want you to also epically fail. So let's say.
I got you, fam.
So let's say, listen to me. Let's
I got
say
ahead of the curve by doing it on the quiz.
you chose the wrong u. You will stay here, you're taking me off my game here. Let's say you chose a u. At what point would you know you went wrong? Jason? The x's all don't cancel. How else would you know you went wrong, Nicole?
When you mean wrong you, what do you mean?
the wrong thing for you.
Like
Like if you accidentally picked 3x for you,
okay.
it wouldn't work out.
Let's do it. What if you chose u equaled 3x? Of course, what else would I have chosen? U equals cos of 5x squared.
Okay.
Which one do you want to
I wasn't
try?
sure what you're talking about.
3x.
Go. Chop, chop. Go. Show me what happens when you choose u equals to 3x. Okay? And then we're going to answer the question, because there's nothing worse than epically failing and not knowing that you epically failed.
There's no x to it.
Okay, well, let's wait. Hold on. Okay, so let's look. U equals 3x. What do you mean to do the thing?
Oh, that's
Very vague.
Three cancel.
I can do it that way, it's different.
Still
Okay.
have to pause it. You can't like, you don't know what to do with it.
Okay. So that's pretty
Well, now you can't. How do you change 3 into cosine 5x
There's no,
squared?
you don't know how to differentiate those.
Yeah, okay, hold on. Yep, I know. Just we've got like places like today when we are at points of we have to just kind of we have to make sure we invite those into the exquisite pain that you all have already experienced. That exquisite pain. Okay, the exquisite pain. Nicola, do you see? Is it clear?
It is quite clear.
Okay, so do you have the right view and then do you
Yeah,
have
yeah.
All right, now I'm gonna sum it back in.
Okay.
Okay, let's see. The antiderivative of that was your view, right?
Yeah.
Yeah. U cosine of 5x squared du.
It's just not like nothing's gonna cancel.
Okay, yeah, so right away, this should raise alarm bells because the only variable appearing in your integrand should be u.
Okay.
Fail, right?
Yeah, okay.
So your first time through, you should find yourself picking wrong u's and seeing I have gotten nowhere. At that process of picking wrong u's helps you get better at picking the correct u's. So one choice of u that I've already given you a hint at is, okay, let's go back. When you have a composition of functions, it's a little more than sometimes, is a little less than often. I'd say like 70% of the time, if you let u equal that inner operation, it should work. Okay? So I offer that to you. This, by the way, is called integration by, the method here is called substitution. Okay? This method is the method of integration by, what's it called? Substitution. Or some people call it U-sub, okay? Integration by substitution.
Like a U-sub.
Or, like, this is kind of like party talk, but like,
It's hard talk.
that's my analogy. I like it.
Logue Jones right there.
Yeah. That's Mr. Logue's party
How do you know
talk.
that it's valid to like cancel the tax there? Like, is the dummy variable just like attached to the integrand?
Well, the dummy variable is always like multiplied by the integrand. So do you see, look back at Mateus. The dummy, look over here. The dummy is always a factor of, so the dummy is always multiplied, so to speak, by the integrand. Okay, so here, this dummy, when you're here, du over 10x, I mean, I can move the 10x, right? I can just do this, 3x cos u over 10x du. du is still a dummy of the integrand.
But like, why do we have dx there, like, multiplied with the integrand when we're taking the integral? So, like, why don't we have
I
dy
know.
or
I know. So the dummy significance is a pretty large conversation. We will get there. You need to still have these mechanics down first. Right now, Jason, so I think part of you are wondering, we've worked with dy and dx, why can't it be dy? Is that what you're wondering? Kind of, yeah. My answer to you right now, which is not a complete one, is that the dummy has to match the integrand as a factor, okay? But that's a great question. All right, let's try something else. Ready? Let's try this.
Could you explain again how cos u and du corresponds to sine u in the
So right here, Cameron.
Yeah.
It's cos u. Du has nothing to do with it. That's just a dummy. It's just saying, what is the antiderivative of 3/10 cos u du? This is no different than this, Cameron. Integral of 3/10 cosine of x dx.
So we just get into a form that we know right then and there how to make it into the
Yes.
regular function.
The other thing is, that's another hint too. When you use U-sub, you know you've gone in the right direction if your integrand is now simpler or more complicated. Simpler, okay? So 2 more to try. And then one is going to be similar, another one is potentially going to make you either exquisitely uncomfortable or joyously happy. I don't know which one, depends on where you are here, okay? Evaluate the following. Are you ready? Here we go. All right. The antiderivative of secant squared x e to the x plus stop and x. You insult me. You insult me. Okay? The antiderivative of secant squared x e to the tan x.
Is each tan x inside secant?
Nope. Oh, yeah, that's a good question. No. Boys and girls, it's secant squared of x times e to the tan x, okay?
Oh.
Don't skip the step of saying, is this the reverse of a simple antiderivative rule? Maybe it's so disgusting you're going to move that out. I don't know, but make sure you always ask that question, okay? And then here's the second one. That's Caroline. E to the x. Actually, E to the x would be a problem.
Who's Caroline? Who's Caroline?
Here is the second one.
What's she called Caroline? Caroline is salsa. I'm gonna Megan. Yeah. Sure though. I suck at this. I already suck at this. Do you plug it in for tannins?
One,
You must, right?
2.
I don't know. That's what I'm gonna try. I'm not very good at this already. Like, I'm already bad at this. How?
It's like, oh yeah, that works. Yeah, that falls.
Oh.
So, one of them should throw you a curveball. Would like to see work up, but I don't want anyone to look up if you're not ready yet. So let's call this 1. Okay, so we all have a comment. Or like step number 1. Megan, you want to do it? Go ahead. Yep. Let's see. Number 2, you have to just dive in because 2 breaks the mold. 2 is different. There's no composite in 2. You have to just dive in and try. Just try.
No, didn't do it. Yeah, I'm gonna start rolling number 2.
Bless you.
Oh my goodness. Did you get e to the tan x plus c? Yeah. Yeah? Okay, good. I did something right.
Yeah, that's fine. I know. Okay, so there's. And then Caroline, I want you to cover that after you do it. So I want you to cover because Sigmar and Boris will stew in on that one. That one, yeah. Kate. I don't know why. Kate and Caroline. I have a Caroline and I have a Kate. And a Christina. And a Kat.
Barkman? Everyone
Yes.
yes.
Yes. You don't
look
I know.
at all.
You don't look alike at all. But I can see it too.
It's the brown.
And you're like you have the same face. You have the big brown eyes, and yeah, I know.
And the
But
smile too.
yeah, it's very. I have Caroline, Kate, Kat, Christina, and Catherine.
Christina?
Christina,
Oh.
Rightel.
Yeah.
Cover it, please. Shoo. Cover it.
No, the answer.
Hey, don't look up. Don't look up.
What is
Threw yourself under the
Alright, so I got
You mean E to the U.
Oh, no,
What is it actually like? It's signing. It's
That's awesome. You know how to integrate U to U, just like you know how to integrate X to X.
Yeah.
Don't
Oh,
you?
yeah, how to do too.
That's the, that's
Anyway, my work.
No, I did myself. It just took a while.
What is UDU?
Number 2.
What is X dx? What's the integral of X dx? Don't let the U throw you. The integral of U du is no different than the integral of X dx.
It's 1/2.
Yes, 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 yes. There has to be no integral there.
Oh.
One half U squared plus C.
Oh my.
Okay.
Oh, yeah.
Oh.
Okay. Who's still trying out the second one? Okay. Yep.
Are we gonna learn doubles? We're gonna learn double.
Is this right?
What was that?
Are we gonna do double yourself? Like, not
Yes.
today,
Yeah,
but
eventually. Yeah.
that was so complicated.
Megan, is this for you guys?
1/2 sine x squared. Yeah, just put the sine x in like parentheses because it's like not sine of x squared, it's like sine x the whole thing squared.
Oh yeah, that makes sense.
So what's your answer? Okay, thanks. You can always check these, right? Differentiate that. You should get this.
I definitely missed like
So let's say equal sine x d. What is it?
I definitely got like a 7.
Yes, integral of u du. What is that? Integral of
So where do you get UDU?
So that's the difference over here. Integral of x. Yes.
The derivative needs to be, because that's just rules.
Is it like negative
Oh, actually, that's squared.
For which one?
What's the U?
Okay, so yeah, so you have sine, so technically you can do both. But if you pick cosine, it's gonna make your life more complicated.
Yeah, I think sine.
So if you pick sine, so if you say u equals sine, right?
Yeah.
So then du dx would equal what?
I need to do
Yeah. So then the way we do it is a little bit different. Like I can show you. So if du dx, yeah. So then if you just bring over to that, you get cosine dx, right? And that's just that whole part. So you can substitute that whole thing with du and then sine u. So then you just get the integral of u dx. Sorry.
Yeah, U to U.
And then that's the same thing with like x dx.
Very good. Yeah, very good.
So like,
How'd you do that?
Uh,
Yeah, this is what Gary did too. You do the same thing. It's so funny. Okay, this there. How did you do this last night?
Last night.
How'd you do that?
Oh, you add 1 to the.
Okay, give me the answer. Yes. So then what's this? May I?
Yeah.
What's this?
Oh, so that's U squared over 2.
Now put the U back in.
Oh, okay.
Paige, how are you?
Good.
Yeah, nice. Good. Nancy, you good? This should be solid for you, yeah? Like totally solid. How are you?
Better be.
Yeah?
Or I think I got lost on the
Yeah. Sine squared and 1/2 sine squared x plus c. Yep, you're all good.
Okay.
Good.
Can we drop the lowest grade on the term?
I'm sure there'll be lower grades.
You have to look at it like this.
That is
You get x squared over 2.
Page.
Yeah.
I
I don't have any left. Sorry. Like I legitimately don't. I'm not lying. Sorry.
No, my math knowledge improved so much in that study period. Like, for me to get a D on that was like,
Why is that 6?
Should I end this recording?
what is that?
I feel like I'm just wasting his time at this point.
Most likely the reason.
It was hard, but we got kind of like a monster.
Yeah, we demo.
Except for
Not Max.
Max, but he chose not to.
Yeah, why?
You scored a
Wait, I thought Jack
one half
did.
you squared.
Miss you.
Yeah. But I had someone, I had typed off and then I saw someone told me did it, but we got it wrong.
Miss Yam, should I end this recording or are we gonna keep doing stuff?
No, I have one more for you.
Oh, okay.
Oh, there's more.
Okay, here we go.
Why did you make a difference?
Because it's literally saying integrate this first. And here's why. If you subs U back in, then you sub DU back in. And DU.
Alright, I'm not really a fan of this whole
Recording.
recording.
Make it unusual.
This is so stupid. I
Yeah,
learned how
you
to
said
do
this
these
only works
problems.
with
So like
substitution,
Oliver's watching me
70%
like
of the
being
time.
really dumb and struggling.
Looking for a composite.
Oh, okay.
Right?
Okay.
Yes.
If you do U equals cosine, you get the different result.
It will be yes, it will
So
be
I know
different.
like different
Okay, this is gonna be a lot of.
things.
You have to get lucky.
Yes.
Yeah, you
Okay.
have to
One
It's
more.
like trig identities.
Yeah.
One deal. There it is. Here we go. Integral. Oh gosh. Oh, this is one of my favorite. It looks so innocent, but
This is not like
I know.
Does it
Oh my god. We're not.
oh, wait, hold on.
Oh, red rock.
Sorry.
Wait.
This one. Sorry, I meant to do this one. That one's too easy.
Dang it.
Yeah, that one is.
Erase it. Erase it. Dave. Erase it.
It's gone.
Erase
That
it.
one is easy.
There. Breaks the mold again. 1 over x times ln x. Yeah, so it was so Nicole and Cameron and Gary, you integrate first, then you put u back in. Okay. You guys jump in and try some stuff. You just try it. Just try it.
It's just one over.
And maybe if you look around, people are trying different use the good things, then we can just kind of share and say, that didn't work, that didn't work, that didn't work. Okay. Okay, yeah, if you chose a U that didn't work, share it. Take a shot in the dark. Take a shot in the dark. Okay, I can think of, oh, by the way, kind of a note to self, it's only a Paige agrees, so maybe I shouldn't volunteer Paige until I ask her first. But if you know you're going to miss and you want to record class, and if Paige is willing and she's not missing class, she's probably like the gold medal standard of note taking. Like her notes are pristine. So,
Well, R2s, I mean,
pardon me?
R2s are unbeatable quality.
Why?
No, I do, but I don't know. I don't think.
Did you just hurt us? Did you just hurt us feelings, Gary? Was that
I don't know.
Yeah.
I thought I did. Joe was
Not
saying the
really.
same thing though, so I don't think he really hurt you.
Wow. Yes, you guys know it. This is great.
Okay, in the interest of time, let's
Okay,
share
I
the
think
U's
that
that didn't
failed.
work.
X.
Okay.
X, L, and X. Or did I? Yeah, you did something different,
Not
right?
work.
Yeah.
Okay.
Okay.
Tell her.
U equals X didn't work. What else didn't work? Share.
XL and X.
Share X.
XL.
XL and
Whole
X.
thing as in what?
That's
What over X, L, and X. Okay.
I think it works with
Just
that.
say XL and X.
What else?
The whole thing. XL and X.
X, L, and X. What else didn't work? 1 over X.
Yeah, whatever.
Oh,
It
you
says
had it
it.
also? No, I just.
Yeah, every
Arrow.
possible
Except for L.
except for natural.
Okay,
R,
everything except
X.
for L.
Yeah.
1 over LMX.
1 over, yeah.
I'm just stating.
All of these didn't work. Oh yeah, the beauty of teamwork. Did anyone find one that worked?
It's
LNX.
LNX.
Yes. If you let U equals LNX, take me through what, listen to my question. Give me the cleaned up integral in terms of U.
1 over u.
1 over u du. Okay, now be careful here. 1 over u du. Do we agree?
Yeah.
Yes.
What is the antiderivative of 1 over u?
Natural
ln
of u.
ln u plus c.
So ln.
So the antiderivative is
ln
natural log
Of
natural log.
log.
ln.
Let's do out.
I wonder what that
And then
graph
it's
is.
natural log. Why would you write n out instead of ln?
Okay. All right, so homework tonight, you can kind of feel what it's going to be. Practice this. Here are your quizzes. I digress. I will say they were outstanding. They were outstanding. Truly. Yes, they were truly outstanding. Here's what I want you to look at, okay? You need to look at, listen please. When you get this back, I'm not going to go over this, it's all review content. What's very important is that you see and look at what kind of error you made.
Okay, sorry.
I looked, most of them that I saw, they were like, you have the negative, or you did 1/2 squared is 1, things like that, okay? I didn't go and circle the right answer. I want you to do that, that's part of fixing your mistake, okay? All right.
No.
Nancy, Jason, Carmen, Cameron, Teo, Cole, okay, Erie, Teo, all right. Adios, everyone. Goodbye. Pleasure.
I'm actually really.
Why? This happens every time.
Oh God. Can we drop things on the screen? Did I drop the notes now? Right.
Okay.
No, I'm gonna do it. Hold on. Wait, no, hold on. That's wrong.
Okay.
Yes. Wait. It's a test. I'm going to ask you 4. Thank you, Ms. Anna. Yeah, you're welcome. Yes.
66. There's 2/3. I actually.
Right, but I have an email.
How am I still doing this problem? How am I this incompetent?
The ones that I missed, I actually knew.
I know how to do this. I'm just like not paying attention. Okay.
Wait, you got the last one?
I didn't walk.
So
I knew that it was 0, but I can't
I know there were 2.
No.
Only one of them.
I knew that it was 0.
Whatever. I got close enough.
That's so.
I'll figure this out later. No, this is.
No, we don't have. I have 5, but you do not have 5.
Oh, right. How many points?
Kiri, I think we dropped.
Yeah, we do drop it there. Okay, this was.
Paige, thank you.
Yeah.
Oliver,
Did
thank
I do
you.
this right?
I'm going to print it out for you. And
Okay, sounds good.
where can I get it to you in a convenient way? Are you going to go over to lunch now? Do you want me to stick it on my, print it and stick it on my desk?
Yeah. Stick it on your desk. That'd be good.
Are you
I feel like I finished this problem, but is that the right answer?
Yep.
Yeah. Okay.
Yep, it
nice.
is.
Put it in a little box.
Nice.
Then I'll be done. All right.
Good. Just pause it.